So let's look now at special and general angles and finding their exact values. Now, if you remember from previous math courses, there are certain triangles we call special triangles, and we're going to use these as our reference. And from these triangles, we can find the exact value of any special angles. So remember our special triangles. Well, first of all, they are 90-degree triangles. And we have our 45, 45, 90-degree triangle. And if you remember, this triangle has sides that correspond to being 1, 1, root 2. The two sides are 1, the hypotenuse is 2. Remember, across from 45 is a 1, and across from the 90 is the root 2. That's how we can remember it when we're trying to draw that special triangle, the 1, 1, root 2 triangle. And remember, our other special triangle is the 30-degree, 60-degree, 90-degree triangle. And again, this one has certain relationships. Across from 30 is 1, across from 90 is 2, and across from 60 is root 3. So this is the 1, 2, root 3 triangle. Now those triangles aren't to scale, but that's okay because we're just going to use those two special triangles to help us find exact values. So let's use these triangles and find our exact values. Remember, we have sine, cosine, and tangent, and from SOHCAHTOA, sine of an angle is the opposite over the hypotenuse, cosine of an angle is the adjacent over the hypotenuse, and tangent is opposite over adjacent. So if we choose the angle, and we're going to start down here with 30 degrees, if we use our 30-degree triangle, the sine of 30 degrees is the opposite, which would be 1 over the hypotenuse, which is 2. Well, the cos of 30 degrees would be adjacent, root 3, and the tan of 30 degrees would be opposite over adjacent, 1 over root 3, which we often write as root 3 over 3 with a rationalized denominator. Now what about 60 degrees? And we can do the same idea here. If we want the sine of 60 degrees, now we just have to consider that the opposite is a different side. The opposite of 60 is root 3, and the hypotenuse, still 2. The adjacent to 60 for cosine is 1 over hypotenuse, 2, and the tangent of 60 is opposite over adjacent, root 3 over 1, which we just write as root 3. Now notice that the sine of 30 and the cos of 60 are the same. That's going to become very important. Well, let's look now at 45 degrees, and we can choose any 45 here. The sine of 45 is 1 over root 2, which again we sometimes write as root 2 over 2. That's just rationalized. Cosine of 45 degrees, same thing, 1 over root 2, which is really root 2 over 2. And the tangent of 45, 1 over 1, which is just 1. Now we can use these special triangles and these special angles to find the exact value of any angle on the coordinate grid. And these are important that we know. We don't have to memorize them. If you know your special triangles, we can do this every single time. The one other piece we have to remember from this, though, is that we've now moved from degrees to radians. So 30 degrees is really the same as pi over 6. 60 degrees is pi over 3, and 45 is pi over 4. So we have to remember our special triangles not only in degrees, but in radians. And that's going to become important when we do questions in radians. This special triangle and exact value allows us to find the special angles as well as multiples of those angles. We just have to follow this technique. We're first going to draw in the correct terminal arm, then sketch in the reference triangle or the angles if we have them. determine the unknown sides, and then find the angle in standard position or give the exact value, depending on the question. So let's apply it to a situation. We want to find the exact value of cos of 3 pi over 4. Well, first step says, draw in the terminal arm in the correct quadrant. So 3 pi over 4 would look like that, quadrant 2. Done, terminal arm is drawn in. Now we want to sketch in the reference triangle. And the reference triangle in this case will be this angle right here. There's our right triangle. Now because it's 3 pi over 4, we know our reference angle is pi over 4. There's our reference angle. And because it's pi over 4, we know that this is a 1, 1, root 2 triangle, which now we have our reference angles and reference triangle drawn in. All of our sides and angles are already known in this case. So all we have to do now is give the angle in standard position. Well, cos of an angle, remember from SOHCAHTOA, is adjacent over hypotenuse. So the cosine of 3 pi over 4 will be, now our adjacent in this case is 1. Now we can use the reference triangle, or we may want to put this in as negative because it's going in the negative x direction. The adjacent is negative 1, and the hypotenuse is root 2, which is the same as negative root 2 over 2. And both are acceptable. It's either negative 1 over root 2 or negative root 2 over 2. And there's the exact value of the cosine of 3 pi over 4. Let's try another. Cotangent of negative 5 pi over 6. So let's just follow our steps. First, draw in the terminal arm. Terminal arm, if we go negative direction, negative 5 pi over 6 puts it right there. Reference triangle will be this triangle right here. And if it's negative 5 pi over 6, the remaining angle in here is pi over 6. There's our reference angle. Now, once we have our reference angle, we can now draw in the angles and the triangle. We have the angle in there. We can draw in the remaining triangle. And we know that this is a 1, 2, root 3 triangle. We may want to put the negatives in this. It's going in the negative x direction, negative y direction. And now we can find the cotangent of any angle. Remember, cotangent is the reciprocal of tan, which means it's going to be adjacent over opposite. So the cotangent of negative 5 pi over 6 will be, the adjacent in this case is negative root 3. The opposite is negative 1, which is really just root 3. There's our exact value of the cotangent of negative 5 pi over 6. Now we don't put that in the calculator and give a decimal. We're going to leave it in radical form. And there are other angles we can find the exact angles for. These are what are called the quadrantal angles. And the quadrantal angles are angles that have their terminal side lying along the coordinate axis. What that means is we want to find angles where a circle crosses the axis. These points, 0, 90, 180, 270, or multiples of pi over 2. Now, we have to keep in mind that we found the sine of any angle. If we were to sketch this in any other point on the circle to find the sine of that value, it was the opposite over hypotenuse, the y over the r. The cosine was x over r, where x is down at the bottom here, that adjacent side now, and tangent was y over x. And cosecant is the reciprocal of sine, so it's just going to be r over y. Secant will be r over x, and cotangent is x over y. Now what we want to consider, though, is what happens when the terminal arm lies right there at that specific point. Now that is still our r value. And what we're going to consider is at that point, we have an xy coordinate. This is the point, -1 and 0. Down here, we're at 0, -1, etc. Here, we're at 1, 0. And up here, we're at 0 and 1. Now, the r value when we are at that point is also equal to 1. That's the length of this radius. Now, at these quadrantal angles, sometimes they have an x coordinate and no y, and sometimes they have a y and no x. But the r is always equal to 1. And we're going to use that information to now find these exact values. So let's start at 0 or 2 pi. At 0, the x coordinate is equal to 1, and the y coordinate is equal to 0. Now, if you look up above, the sine of theta is y over r. Remember, our r is always going to equal 1, so y over r is 0 over 1, which is 0. So the sine of 0, or the sine of 2 pi, is actually 0. What about cosine? Well, cosine is x over r. X in this case is 1. R is 1. So the cosine of 2 pi, or 0, is 1. Well, what about tangent? Tangent is y over x, 0 over 1, which of course is 0. And now we have to be careful because cosecant is the reciprocal of sine. It is r over y. Now, if we remember, dividing by 0 is not allowed. So the cosecant at 0 or 2 pi is actually undefined at that point. We have a 1 over a 0, so it's undefined at that point. Secant, well, just the reciprocal of cos, pretty easy to do, there's just 1. And cotangent again, we have to be careful here. Cotangent would be x over y, 1 over 0, and again, that's also undefined. So see if you can use this and fill in the rest of the chart to determine what are the exact values at those quadrantal angles. Now, after a lot of work, there's our chart filled out and we can find those values. Now, this chart, this exercise, is to show you, you really actually only need to remember a few things to find these quadrantal angles. And hopefully you've noticed a pattern here. When we look at the sine of theta, the sine of theta corresponds to all the y values. At any point, the sine of theta is just y. And the cos of theta is actually just the x coordinate. And because we have cos and sine, the x and y, we can find any quadrantal angle very quickly. The reciprocal, cosecant and secant, or we can use a relationship for tangent. And this is a relationship we're going to use quite a bit. Tangent of an angle is really the sine of an angle over the cos of an angle, which is really what we already know, opposite y over x. So though this chart may seem complex, we're just going to remember that sine of theta is y, cos of theta is x, and everything can go from there. So let's try. Determine the value of theta where the cotangent of x is equal to 0. Well, now we're going to work backwards. First of all, cotangent is 0. We know we are at one of our quadrantal angles. So we are at one of our points on the circle. We're not sure which one, but we can figure this out. Cotangent of theta, cotangent is the reciprocal of tan. Tangent is y over x, so cotangent is x over y. Now we want this to equal 0. That means for this to equal 0, our x coordinate must be equal to 0. We must have a fraction that we can divide by a number and get 0. So all that we need is this. Find out where is x equal to 0. Well, there's 2 points. X equals 0 right here and right here. The y coordinates are 1 and -1 respectively, but x is equal to 0. So what are those angles? Well, theta then must be pi over 2 and 3 pi over 2. And because we have that quadrantal angle, we know that we can find any of the values. So let's try one more. Where is secant theta undefined? Now secant is the same as 1 over cos theta. And remember, cos theta is x over r. So 1 over cos theta is r over x. And we want to find out where is this undefined. Well, for this to be undefined, again, our x coordinate must equal 0. That's going to put a 0 in the denominator and make this solution undefined. So we go back to our quadrantal angles and we figure out where is x equal to 0. Well, x is equal to 0 at 2 points we did before. There they are. That's where x is equal to 0, and our theta that corresponds to that would be pi over 2 and 3 pi over 2. So the important piece to get out from these types of questions is that if the value is 1, 0, or undefined, it's going to be a quadrantal angle. And those quadrantal angles, we're just looking for x and y, and using the circle, which we sometimes call the unit circle. Unit because it has a radius equal to 1, and we can use that value to find any of those exact quadrantal values.